Okay, let's look at a population problem, and we're going to deal with a similar population problem to one that you have been presented with on the essays, in which we're going to have a country whose initial population is 999 million, and it's growing at 0.7% a year, so that is our exponent. And I'm just going to make a little note off on the side, say that t is the time since 2000. And let's pretend, for whatever reason, that we are interested in when that population will reach 200,000 million, or 2 billion people. So we're going to fill 2,000 in for our A, or our end population, and keep the rest of the formula the same. Now I do just want to make an important note for your essay question. I know it looks like that exponent, which they actually wrote out for you, is down next to the E, and that's not the case. It is up on top as an exponent. Okay, the next thing we're going to do is we're going to get that E alone by dividing out that 999. So we are left with 2.002 is e to the 0.007t. And here's where the important factor comes, that exponent is up on top in the exponent and not being multiplied by the t, because we're going to deal with it differently. In order to get that exponent out of there, we're going to take the natural log of both sides. And that allows us to bring the exponent from the exponent down in front of the natural log of e. Now you'll remember the natural log of e is actually 1. So what we're really dealing with is ln of 2.002 equals 0.007t. So in order to get t alone, I'm going to divide by 0.007. Now, if you're working with a calculator, I'm sure you guys all have different calculators. You do want to make sure you're using the ln key, not the log key. And if you can't find the ln key, you can send me the make model of your calculator, and I should be able to help you figure it out based on a picture from good old Google. Or you can use the ln function. It is on the calculator on the computer, but you do have to be sure that that's in scientific view. Now what I'm going to get is t equals 99.1 years. Now it's important to note that the population, although I know you would probably really round this to 99 years, the population will not quite have doubled in 99 years. It won't quite have, or not quite doubled, it won't quite have reached that 2,000 million mark or 2 billion mark. So we do want to be careful when we round. It won't quite have reached our goal. So in this case we actually kind of violate our rounding rules and say 99.1 rounds to 100 years, just because we won't have quite met that goal we set forth for ourselves. Now remember, this is not in the year 100, this is the number of years after the year 2000, so the actual year in which this will occur is 2100, and that's going to be when our population has reached that that goal. Now it will be fairly early in 2100 because it was 99.1 years, so it's just after 99 years it will have reached that goal.